Logarithms and natural logarithms have some fundamental facts about them that can help simplify the logs down and make them easier to work with without the aid of a calculator. So the first thing we're going to look at is the properties of just logs. And these four are log base b of 1, so some log of some base that has 1 in the argument will always be 0. If you log b of b, it will always be 1. If you have log b of b to the x, it will always be x. And if you have b raised to the log b of x, it will be x. So let's see a couple in practice. We have log base 3 of 3 raised to the 71st power, and we're going to evaluate without a calculator. So I see here that I have log base 3 of 3. The base and the argument are the exact same, similar to what is in this one here, which means that when you simplify it, it's just going to be the exponent. So in this case, log base 3 of 71 is just going to be 71. And that's how you do that, using the properties of logs. Now we have log base pi of 1. The pi is there to throw you off, make you think something else is going on when it's not. All you need to know is that in the argument is a 1. And if there's a 1 in the argument, the answer is 0. So log base pi of 1 is just going to be 0. And that's it. Last we have 2 raised to the log base 2 of x. And that's going to fit into this property right here, where the base and the exponents, or the base that's raising it and the base of the log, are the exact same. So the 2, log 2, are the exact same. They are going to just knock each other out, essentially, leave you with just the argument x. And so that's how some of the properties of log work here with these kind of examples. They all follow the same steps. If they fit in here, just do what it says. Now, let's look at some natural logs. They are essentially the exact same thing, just ln instead of log. If you have ln of 1, it's always 0. ln e is going to just be 1. ln e raised to the x is just going to be x. And e raised to the ln x is just x. So a lot of these are the exact same that we did before, except we're using e's and ln's. So here we have ln e raised to the -4th. This is similar to this one here, where we just end up with the exponent, because the ln and the e knock each other out. So here, our answer is just going to be -4. Right here we have 9 ln 1. The 9 again is here to throw you off, but don't be fooled. This is just 9 times ln 1. So we look up here at ln 1, and we see that anything that has a 1 in here, a log that has a 1 in there, is just going to be 0. So I'm just going to get 9 times 0, which is just going to be 0. So again, the 9 is there to throw you off. Don't be fooled. Just focus on what the properties say and go with that. Last, we have e raised to the ln 12. And so we're going to look at here and we see that e raised to ln of x. The e and the ln knock each other out, leaving you with just what's inside the argument, which is x. So in ours, the e ln are going to cancel each other out, leaving you with just what's inside the argument, which in this case is 12. So again, these are how the natural logs work with their properties, similar to the regular logs.